Alright, Assalamu alaikum guys. We're going to be looking at solving one-step equations today, and I think some two-step equations as well. Obviously your journey with this topic began last year. If I do recall, yeah, there's some equations you do in year 7. But we're going to elaborate on what we learned yesterday by applying inverse operations. And basically, the main goal is to isolate the pronumeral in each question and then have it equal to a particular number. So just real quickly to identify, these are what are called pronumerals, these letters. So the letters we use in algebra and equations, we refer to them as pronumerals. And with equations, the goal is to isolate it completely. Now, if we look at this first equation, we have to take note. When we deal with equations, we are dealing with two sides, and the two sides are separated by this equal symbol. Okay, that equal symbol indicates that there's the left hand side and the right hand side. So the objective here is to isolate the left hand side completely and leave x on its own. So in order to do that, I need to get rid of this positive 3. And what I like to do here, to get rid of this plus 3, I will do its inverse operation. So the inverse of plus 3 is minus 3. And there's a rule in maths: what I do to one side of an equation, I must also do to the other side of the equation. Remember, the equal sign separates the sides. So therefore, I do that to there. Now, positive 3 and negative 3, they will actually cancel each other out. And then I'm left with just an x on the left side. And that was my goal, to isolate the x completely. And then on the right side, we have 12 take away 3, which gives us 9. And that's our first answer. And as you can see, that is, it's called one-step equation for that reason, because it takes one step to resolve this answer. All right, let's move on to the next one. Again, we have the left-hand side, the right-hand side, and we are trying to isolate the left-hand side so that the x is on its own. And we can see here we have a negative 7. Now, to do the inverse operation of negative 7, we will add 7 to both sides. And there we go. So negative 7 plus 7 will remove itself. And then on the right-hand side, on the left-hand side, I've isolated the x now. On the right-hand side, we have 2 plus 7, which will give us 9. Okay. It's just a coincidence that the answers are the same. But yeah, that's what we objectively do. Now over here, 8 plus p equals 14. As you can notice, this time the 8 and the p have swapped positions. That has no bearing on how we resolve the problem. We are still trying to isolate p. So the goal is still for isolating p. So I need to get rid of this 8. And right now, there's no plus here, but that's actually plus 8. So the inverse operation of plus 8 is minus 8. And we do that to both sides, so we get a similar result. So now from here, now I've isolated the p. And on the right-hand side, we have 14 take away 8, which gives us 6. And that's that. All right, so that's how we deal with pluses and minuses. What about in a situation where we have multiplication? Where's the multiplication, you ask? Well, 7y means 7 times y. And quickly on that note, what is the inverse operation of multiplication? Well, the inverse operation of multiplication is division. Now, another way to do division is to write things in fractional form. So I can write divide 7, but it's a little less intuitive, and I think the better approach would be to do the fraction. So over 7, just like that. 7y over 7. What I do to the left-hand side, I will do to the right-hand side. And here, 7 divided by 7 will cancel out to become 1. And then I'm left with the y on its own on the left side. And then we have 35 divided by 7, which will give us 5. Just like that. Okay, so hopefully there's no issues on that. Moving down to this example. This time we have the 2 dividing the x. So remember, the fractional line means divide. We have 2 dividing the x, so x divided by 2. So the opposite operation of divide is by multiplying. So if I multiply the numerator, and you have to do it specifically to the numerator. If I multiply the numerator by 2, and I multiply this side by 2 as well, because what you do to one side, you have to do to the other, then the 2's on this side will actually cancel themselves out. And therefore, I'm left with x on its own. And then here we have 5 times 2. That will give us 10. And it's as simple as that, guys. So hopefully that quick recap helped you remember everything from last year. Now let's move on to some situations that involve negative integers. So solve these one-step equations that involve negative integers. All right, so it's the same process. We look at the left side, we look at the right side. On the left side, I need to isolate x. So I'm going to minus the 3 from both sides. And we are left with x equals -2. In the next example, we have the 5 in the p swapping position. So that doesn't matter. My goal is still to isolate the p. Again, this 5 has a positive in front of it. So we have to do its inverse operation, which is minusing 5. Minusing 5 to both sides. That cancels itself out. And then we have -1 take away 5. A lot of people mix up their negatives. -1 take away 5 is -6. You can confirm that in the calculator. All right, and that's what we get there. Just a heads up, guys, if you're struggling to do some of the actual operations, feel free to use a calculator, but it is highly recommended and advised that you get your mental maths a bit stronger. All right, moving on to this one. Again, let's recall that 3a means 3 times a. So the inverse operation of multiply is divide. So we're going to divide by 3 on both sides. The 3 will cancel out. And then over here, we have a isolated, which was our objective. And here we have 12 divided by 3, which is 4. But there's a single negative, so that negative will remain. Okay. And now, over here, we have v divided by -3. So the inverse operation of divide is times, so we're going to multiply by -3, and what we do to one side we must do to the other. The negatives here will cancel. The -3 here will cancel out. We've isolated v, and now we do 5 times 3. 5 times 3 is 15, but in addition to that we have a negative and a negative multiplying. So when two negatives multiply, the result becomes positive. So therefore the answer is just v equals 15, just like that. All right, let's move on to this one. It seems like a difficult question. It's really not. So there's a number of ways you can do this. First way, you can ignore the bracket. So let's imagine we rub that out. Now, what we've been taught in the past is two negatives that are immediately next to each other, they will become a plus. It's kind of like what happened here. If you multiply two negatives together, it becomes a positive. Well, if two negatives are next to each other, they'll also become a positive. So that we can change it to t plus 8 equals 10. All right. But what this does, it actually turns this into a two-step. Okay, so I don't think that's the objective of the exercise. I think the way the textbook wants you to do it is, let's rewrite the question here. The way the question wants you to do it, they want you to do the inverse operation of this negative here. So that inverse operation would be plus of -8, plus of -8, and then we're left with t equals, and this is like reading 10 plus minus 8. That's effectively the same thing as what I showed over here, just a bit faster. Plus minus will become minus, so it's actually 10 take away 8, and that will give us 2, the same result. All right, if you need to recap anything, don't forget to pause, rewind, play, just to double check any steps you are unsure of. Let's move on. All right, so now substitute the solution into each equation below and state whether the solution is correct or not. So this is the solution or the proposed solution. There's a way to check if you've been doing your equations correctly, and that's by substituting your answer into the original question. So technically, if you're in an exam, you can almost guarantee whether you've gained a mark or lost a mark. All right, so let's show how we would do this. Now, to substitute, we take this 56, and its value is it's equal to x, and we're going to replace it with x in the original question. So 56 plus 17. If we calculate this, we end up with 73. Now, there's a bit of a problem. 73 and 39 do not match. So therefore, this is an incorrect solution. 56 is not the answer. So imagine you were doing this problem, and then you got 56, and then you did this test well, you will know that you did it incorrectly. Okay, let's try the next one. Q take away 13 equals 16, Q equals 29. We're going to take this 29, we're going to replace it with the Q. So we have 29 take away 13, which equals 16, which it does. And look at that, it balanced. So 16 equals 16, therefore this is correct. So that means the answer to this is going to be 29. Over here, 5n equals 35. We're going to take this 7 and put it right there. Now remember, you're not writing 57. That makes no sense. 5n means 5 times n. So 5 times 7. Well, calculating that, we get 35. And we can see that's equal to 35. So the good news there, that's the actual answer. So this is correct as well. And then finally, this question here, we're going to take this 4. We're going to substitute it into the numerator here. We get 4 over 2, which is the same as saying 4 divided by 2. And 4 divided by 2 is, in fact, 2. And 2 does not equal 8, as they have provided. So this one is incorrect as well. All right. Let's move on to question 4. So now these are two-step equations, and they'll require you to obviously use 2 steps, but probably first to move a term, and then secondly to divide or multiply a term. So let's get started with 2x plus 3 equals 7. Now the objective is to isolate the x, but if a number is attached, then we actually try and isolate the whole thing for now. So we're going to try and isolate 2x first. That means we have a plus 3 to get rid of. So we're minus 3 from both sides. We are left with 2x equals 4. So that's the first step down. And then finally, this means 2 times x. The opposite of times is divide. So we're going to divide both sides by 2. And we end up with x equals 4 divided by 2, which is 2. And there we go. That's the answer. Let's move on to the next one. Over here, we have 6k take away 5 equals 7. All right, so again, we're going to isolate 6k. So let's add 5 to both sides. Remember, we're doing inverse operations. And then we have 6k equals to 12. Again, this means 6 times k. So we're going to apply the inverse operation by dividing by 6. And then we're left with k is equal to 2. All right, look at this question. It's somewhat challenging. It's not really, but your goal remains the same. You're trying to isolate not 3w, but negative 3w. So you have to be wary of this. This negative belongs to 3w. So we're trying to isolate negative 3w. That means I need to get rid of this 2. And this 2, if you recall, the first term, if it comes as the first term, it's a plus if there's no sign in front of it. So we're going to get rid of that. And then on the left side, I'm left with just negative 3w. And over here, 11 take away 2 is 9. Okay. And now one more step. I need to isolate the w. So this is negative 3 times w. To get rid of negative 3, I divide it to both sides. And there we go. So we end up with w equals, and you can put this in a calculator if you want, but real quickly, this is 9 divided by 3, which is 3. There's one negative, so the answer will stay negative. And that's that. Now, with a question like this, it might help you to rewrite it and put the letters on the left side. All right, this is a tactic I've seen used by some students over the years that just helps them to understand things better. That's not really a step. Some people just like to rewrite the question with the pronumeral on the side that they prefer. Some people can solve like this. There's no issue with that. But some people prefer to isolate the letter or the pronumeral on the left side. So let's begin. We begin by isolating 2y. That means we've got to get rid of 8. So that 8 is a positive, and I need to get rid of it by minusing from both sides. And just like that, we have 2y equals to 30 take away 8, which is 22. And then we have here 2 times y. The opposite of multiplying is divide. We divide both sides. And we get 22 divided by 2, which is 11. And that's that. All right, moving on. So some more two-step equations. A bit more complicated. There's more fraction usage here. But let's begin. So 5x divided by 2 equals 5. Now, whenever I get this type of question, one of the first things I usually like to do is get rid of the denominator. All right now it's dividing by 2. So that means I'll multiply by 2 to both sides. Okay, so we're left with 5x equals 10. All right, perfect. And now we have here 5 times x. 5 times x. So the opposite of, or the inverse operation of multiplying by 5 is dividing by 5. And what I do to one side, I do to the other. So here we're left with x equals 10 divided by 5, which is 2. There we go. All right, next step. Again, here we have more terms in the numerator. However, this is still considered a single term. That means I can actually get rid of this 2 the same way as I did in the previous example. So it's divide by 2 right now. We're going to multiply by 2 to both sides. That 2 will cancel out. And I'm left with a little bit of an expression from the numerator. All right, 5 times 2 is 10. So look at that. We now have a one-step equation. Well, obviously, there's 2 steps because this is the first step. But we have what's seemingly a one-step equation. So now I need to get rid of this negative 7. I add 7 to both sides. Y equals to 3. All right, that's that. Now, the next example, x divided by 2 plus 1 equals 5. So here's the problem. Now, over here we had a minus in between, but this minus was stuck inside of this single fraction. However, over here, we can see there are distinctly 2 terms. So in this case, I'm not going to get rid of the 2 first. I'm actually going to get rid of this 1 first. So you have to be able to make that distinction. All right, so if it's a single term fraction like this, you can multiply it to get rid of the denominator straight away. But if it's 2 terms like this, it's best to get rid of any trailing numbers or on the left or on the left side. Okay, so we're left with, 1 second. We're left with x over 2 equals to 4. And then it's as easy as what we were doing before. Multiply 2 to both sides. We're left with x equals to 8. All right, on the next one, we have, again, the letter's position is swapped. That has no bearing on how we understand this. I'm trying to get rid of the, I'm trying to isolate the q, but that 4 is attached to it, so I have to leave that till the end. Let's get rid of this 3 first. So that's a plus 3. Remember, if it's a first term, it's a plus 3. The inverse operation is minus 3. That will go now, and we're left with q over 4 equals 5. And now, as easy as the previous question, we have q divided by 4. So I do its inverse operation by multiplying by 4. And we end up with q equals 20, because 5 times 4 is 20. All right. Find the solutions to each of the following equations. So this is just some more random questions. I'll do them much faster now. So just pay attention to how I'm doing it. And if I need to comment, I'll comment. Okay, so in this one, the questions are going to be fractions. So that's the catch here. But hopefully all the steps you're seeing that I'm doing are familiar to you by now. Over here, we're going to add 4 to both sides. All right, and then finally we divide by 6. And it doesn't matter if it's a fraction. I'm going to leave my answer as a fraction just like that. Okay, over here, the 2j is the second term. That doesn't matter. We get rid of plus 15 by minusing 15 from both sides. So minus 2j equals negative 9. Make sure you check your calculator to get that correct. And here we divide by negative 2. We know here the 2 will disappear, so we're left with j. But here's something interesting. 9 over 2 is going to be positive. sorry, 9 over 2, we're just going to write 9 over 2 first. But if you notice here, the two negatives, they're dividing each other. They'll actually become positive. So my answer stays as positive 9 over 2. So don't forget, if you multiply or divide by two negatives, the answer is going to be positive. All right, and over here, you can see that the second term, the right-hand side contains the pronumeral. I'm going to rewrite this to have the pronumerals on the side that I want. And then from here, we can see there's a +8, and we're going to proceed as normal. So we end up with 2y equals 13. Divide by 2. Y equals 13 on 2. Now, it's fine to leave your answers as simple fractions like this. You can also do mixed numerals. As you can see, I'm doing for the second example, the third example, and now the fourth example. These are fine as well. You won't be deducted for any marks for either form that you leave the answer in. All right, I just wanted to point that out. All right, question 7 now. So the extension questions. Solve this set of equations which are either one or two step types. So this one just mixed up everything. You've just got to be able to identify which one that is. And just like the previous question, I'm just going to be running through it. Okay, and we end up with y equals to 7. All right, let's do the next one. So the 2y here is negative. So I'm just going to deal with the 5 first. And then here we divide by the negative number. And look at this. 4 divided by 2 is 2. But the answer contains one negative, so the answer is -2. All right, 5y equals 9, that's a one-step equation. Just divide both sides by 5. Done. And if you want, you can write your answer as a mixed numeral. And then over here, two-step equation. Multiply both sides by 8, so getting rid of that denominator first. We end up with 3a equals 16. And then finally dividing by 3. A equals 16 on 3. Or if you like mixed numerals, 5 and 1/3. And now finally, this equation here. So we have a single term here on the left side. It's not a split term like we looked at in the previous question. That means I can multiply by 3 to both sides. We end up with 6 minus a equals 9. And again, I want to isolate this negative a. This is a +6, so we -6 from both sides. We get negative a equals 3. And then here, notice this has a negative. You can actually just swap it to that side. So the answer would become a equals -3. The other way this can work, suppose we had this, that means we make both positive. Remember, maths is nice like that. It always wants to deal with opposite operations. So just keep that in mind as you're doing all of these questions. Apart from that, please finish the exercise 902 and should be all set for when we see each other again. Assalamu alaikum, guys.